students, today we are going to learn how to draw the ray diagram for the image formed by a lens. We will learn rules for both the types of lens together. Let's start from a convex lens. For that, let's draw a vertical dotted line for the lens. Now, let's make a horizontal line approximately mid from the vertical line. So, it acts as a principal axis. Let's make a convex lens, and as we have done in the previous video, 90, let's keep the 90 degree at the principal axis and 60 and 120 in the vertical dotted line. And you know, this vertical dotted line acts as optical axis. Let's complete the curve from both the sides so that we will get a convex lens. In this way, we got a convex lens. Now remove the unwanted part, dotted line, using eraser. Okay. Now let's find the focus. We have to select both sides equal distance for focus. So according to your wish, you can take both sides equal distance. So here I have selected 2 centimeter both sides. We can show optical center also, but that's not necessary for this rule. Let's send one ray parallel to the principal axis, and in case of convex lens, it will pass through the focus after refraction. So one rule is a ray passing through parallel to the principal axis will pass through focus of the lens. Now let's do for concave lens too. So let's begin with the dotted line, vertical dotted line. Now let's make a principal axis just like before. I used to take 6 centimeter at the center, that's why. Okay, now let's make a concave lens. Again 90 at the principal axis and 60 and 120. Let's make a curve from opposite side also. And let's join the ends of the curve so that we will get a concave lens. Concave lens is also called diverging lens. So it diverges the rays of light falling on it. Okay, so in this case we will get a different type of ray than that of the previous one. First one is convex lens, and this is a concave lens. So here we will get virtual focus. See, so virtual focus means the ray will not pass through that, but it appears to pass through the focus. Okay, so let's send a parallel ray to the principal axis, and as it is diverging lens, so the ray will go away from the focus, but it appears to pass through the focus. Okay, so virtual we can draw the dotted line and complete this. Okay, a parallel ray of light appears to pass through the focus of a concave lens. This is one rule. Now let's move to the second rule for a convex lens and then for a concave lens. So in this way, again we'll draw a convex lens and principal axis as before. So let's in this case we are showing focus previously, no problem. You can show the focus later also and previous also, but equal distance from both sides from the optical center. So thinking on this, you can take equal interval in inch also, in centimeter also, so 3 centimeter, 2 centimeter as you can, but I used to select 2 centimeter distance for focal length. This is for the second rule. This rule tells us that a ray of light passing through optical center, you know that principal axis and optical axis meet at a point, and that point is optical center, okay, and equal distance from both sides, that will be f. So here f is showing f, right side f, and the middle point is O, optical center. And one rule is a ray of light passing through optical center, it goes without deviation. It means a ray of light will pass straight without bending, either in case of convex lens or in case of concave lens. So let's do for a concave lens also. Let's draw a vertical dotted line as we have done in the previous rule. Draw a principal axis. I used to take 6 centimeter as the optical center and 4 and 8 as the focus. So now let's make a concave lens. 90 in the principal axis and 60 and 120 above that and below. In this way, from opposite side also we can make, okay, 90 should be in the principal axis and 60 and 120. And just keep one thing in mind, that optical axis should be at equidistance from both the side of the lens, okay, because optical axis, that vertical dotted line, optical axis here is vertical dotted line, and that should be always be equidistant from both the edges so that it looks better. And we have to as we have done earlier, we have already chosen this f on both sides of the lens. So let's write there f on both sides, left side, right side. Okay, now let's send one ray through optical center as we have done for the convex lens. It is same for a concave lens also. Now let's move for third rule, and we'll do for convex lens only. Okay, this rule is not required for our class in case of concave lens. So here I will show you for convex lens only, and again we are going to do the same as we have done in both the rules, convex lens and the principal axis. So f, this point acts as f both sides, and let's make a convex lens. 90 in the principal axis and 60 and 120 in the optical axis. As we have told you that a vertical dotted line acts as a optical axis, and horizontal line, that is a principal axis. This is the third rule. This rule is just converse of the first rule. In first rule we had learned that a ray parallel to principal axis pass through focus of a convex lens after refraction. Here we are going to send one ray through focus of a convex lens, and it becomes parallel to the principal axis after refraction. Okay, so one ray passing through focus after striking to the lens, it becomes parallel to the principal axis. This is, we can say, converse of the first rule. First rule, parallel ray through focus. Here ray through focus becomes parallel to the principal axis. This is third rule. By using these rules we will make any ray diagram. So now for simplicity I have drawn a ray diagram for a convex lens by placing an object beyond 2f. Only one I am going to show here, just an example. So let's draw. Okay, let's divide this line in 5 equal parts at least. So I have selected, as I have told you earlier, mine is 2 centimeter gap. So 2 centimeter, 4 centimeter, 6 centimeter, 8 centimeter and 10 centimeter. We require 5 intervals, and in the middle one, means 6 centimeter, let's draw a vertical dotted line for a convex lens. Now let's make a convex lens. As we have already divided this principal axis into 5 parts. Okay, so that is 2 centimeter, 4 centimeter, 6 centimeter. Oh, this is optical center at the 6 centimeter, F at the double of F, 2F. This is for 8 centimeter, F, and this is 2F. Okay, you can do this for by taking equal distance in inch also. So 1 inch, 2 inch, 3 inch, 4 inch and 5 inch. And in the third we can draw the lens. Okay, now as we have planned to make a ray diagram by placing an object beyond 2f, so we have to make an object beyond 2f. Let's make an object beyond 2f, but keep it in mind, this height should be half of the lens. Okay, A and B. This is for object. AB here is an object, and draw the ray diagram for this. So let's use the first rule as we have learned. Let's send one ray parallel to the principal axis from the top of the object, and this ray will pass through the focus. In case of convex lens, let's send it through the focus of a convex lens, as it is converging lens, so it converges the ray. Another rule, from the top of the object, let's send the ray through optical center O, and at least we require 2 rays to form the image. Okay, so we have done here. We can take a third ray also, but that is not required for us. So just 2 rays we require at least. So we have done for 2 rays, and these 2 rays are meeting at a point in between F and 2F. So that is the place where the image will be formed. Okay, so draw a vertical line, and obviously this is the position of the image. A dash B dash is the image. Okay, in this way a convex lens form